Hello, this is Dr. Amudapriya, Associate Professor Triply, Rohini College of Engineering and Technology, Palkuram. We are discussing about the theory course power system analysis, and in this lecture we will be seeing about the calculation of the unsymmetrical faults like LL fault, LG fault and LLG faults. LL is nothing but the single line to ground fault. We can see here that we do have a three-phase line, out of which a single line is alone connected to the ground directly. I mean the fault is being occurring at the phase A. So obviously the phase current IA will be flowing to the ground. We do have a fault impedance there. And rest of the IB and I0 current will be equal to 0 because the total current in the line will be flowing because of the fault to the ground through A itself. So IB, IC will be obviously equal to 0. So what about the A voltage? VA is equal to ZF into IA because only the fault impedance is going to be there. And in case of symmetrical analysis, IA1, IA2, IA0 is equal to IA by 3. IA1 is equal to EA divided by Z1 plus Z2 plus Z0 plus 3ZF. This is what is going to be happening in case of single line to ground fault. Next, when we are considering the LL line to line fault, we can see that the B phase and the C phase are being connected through the fault impedance Z. So here the IA current will be equal to 0 because the fault has occurred between the phase B and C. And IC is equal to minus IB because if one is going to be acting as a go phase, the other will be a return phase. So IC is equal to minus IB. Obviously their voltage difference will consist of the magnitude current IB or IC, whatever it is. So VB minus VC is equal to IB into ZF. And while considering the sequence network, IA2 is equal to minus IA1 and IA0 is equal to 0. So VA1 minus VA2 is equal to ZF into IA1. Therefore IA1 is equal to EA by Z1 plus Z2 into 3ZF. And IB is equal to minus IC is equal to minus JEA divided by Z1 plus Z2 plus 3ZF. This is the case of line to line fault. When you are considering the double line to ground fault, obviously we can see that IB and IC are connected to each other and through which it has been connected to the ground through the ZF impedance. So IA0 is equal to 0 here and also IA1 plus IA2 plus IA0 is equal to 0. Therefore, VB and VC will be equal and this is equal to ZF into IB plus IC because they are going to totally add up. This is not going to be a go and return case. Both IB and IC totally will be adding to flow through the ZF value. Hence, we can have it as 3ZF into IA0. VA0 minus VA1 is equal to VB, which is equal to 3ZF into IA0. Therefore, IA1 is equal to EA divided by Z1 plus Z2 into Z0 plus 3ZF divided by Z2 plus Z0 plus 3ZF. What is the formula? They are being parallel in nature. Z2 and Z0 plus 3ZF are in parallel nature, hence we have obtained this formula. While considering the unbalanced fault analysis using the bus impedance matrix, here we can see for the single line to ground fault, we can consider the fault at A. Similarly, we used to have that IA, IC and the zero sequence positive sequence and the negative sequence values of the current can be equated to the VK0 divided by the impedances at all the sequences plus the fault impedance into 3 times the fault impedance. We can have the ZKK 1, 2, 0 as the diagonal elements in the K axis of the Z bus and VK of 0 is a pre-fault voltage at bus K. Therefore, the phase current, fault phase current IK ABC is equal to A into IK 012, the sequence values here. Thereby, the line to line fault can be considered in this case. For single line to ground fault, we can calculate the current as such. For line to line fault, It is obvious that IK0 is equal to 0 and IK1 is equal to minus IK2, and this is the equation. For the double line to the ground fault, obviously IKF is equal to IKB plus IKC. Regarding the bus voltages and the line currents during the fault, we know the I0 of F, I mean the fault voltage at the zero sequence, is equal to minus ZIK0 IK0. But in case of positive sequence, we get Vi0 of 0 minus ZIK1 into IK1. I mean the Vi0 of 0 is nothing but the pre-fault voltage. And next, Vi2 of F is equal to 0 ZIK2 IK2. From this, we can calculate the IIJ0, IIJ1 and IIJ2 value. I mean the sequence values of the double line to ground fault. Easily, in this method, we can find out the bus voltages and the line currents. Thank you.